Hi everyone. The topic of current presentation is the method of converting the monolithic architecture of front-end application to microfrontends. Let's talk about motivation. Just imagine you are the developer on some great project with a beautiful microservice architecture. Each service is developed by a separate team. Services are tested and deployed in isolation. But let's back from heaven to earth and see what we have on front-end. Here is a typical single-page application. It's designed with modern framework, but it's a monolithic by its nature, with all the disadvantages of this architecture. So we think maybe we can do something like this. Apply microfrontends. So you go to the architecture of your project and display this scheme to him. And what would be his answer, in your opinion? No way. And problem isn't just a necessary refactoring, but in specific of the front-end applications, which makes the migration a very tricky process. Your code is executed on the client machine. You have only one address bar, one browser object model, one document object model, and you still need one main application to manage other microservices. So here we understand that we need some method that will allow us to make this migration in rather simple, predictable and not risky as much as possible steps. Let's back to microservices. There are a lot of works and articles about systems reengineering, but we will be interested in the Paolo Di Francesca's article about migration to microservice inspired by Horseshoe model of reengineering system by Kazman. He describes the migration in 3 steps. On reverse engineering step, pre-existing system is analyzed to determine legacy code as a candidate to be transformed into microservices. On the step of architecture transformation, we are restructuring pre-existing architecture into microservice-based. And on the last step, we finalize, implement, and deploy microservices. In our research, we will adopt these steps to be applied for microfrontends migration. We have modern applications, so our motivation to get all advantages of the architecture, but not just removing legacy code, like in previous methods. So on reverse engineering step, we move accent to functional analysis, and following function unifying, grouping, or dividing. On the next step, we need to provide business function analysis to determine the main domains of application. On this stage, we need to re-engineer our business models to break code coupling as much as possible. By the end of the step, all the logic by specific domain is moved to independent model. On the forward engineering step, we need to choose the technology to apply microfrontends. Big domain models are moved to microfrontends and deployed separately. Okay, we have method and we need to prove it on practice. For our experiments, we choose existing application chess tutorials. It's a typical single-page application designed on Angular framework. On the first step, we made some refactoring by separating functions related to authorization and student entities, change routing little bit, upgrade Angular to higher version, etc. On the next step of architecture transformation, we determine main business domain of the application, lessons, students, groups, with subdomain statistics. Student model was rebuilt to separate it from system user model. Code related to the main domains was concentrated in separate modules. On the last stage, we apply feature of Webpack module federation to work with microfrontends. Currently, it's the most modern and suitable way to work with microfrontends, to allow good communication between microfrontends and to avoid code duplication. New microfrontend applications were created and main domain were moved from main application to them. After that, we set up shell application to import just domain modules from our microfrontends and deployed all the applications, shell and microfrontends. Conclusion. Existing methods of migration to microservices are adopted to be acceptable for microfrontends. In current work, steps of converting and new states of the application are defined and described to take into account the limitation of the front-end application, which was not covered in previous articles. New proposed step with transformation to modular architecture allow it to minimize the risk of wrong division into microfrontends by breaking the coupling between components before their implementation. Experiments with the typical front-end application proved that proposed method of converting could be applied in real life. Future work. We want to continue to explore the concept of domain-driven design for more efficient domain identification and microfrontend separation. Better understanding of conceptions of the strategic design and the boundary context allow us to design better domain model and, as a result, better isolated microfrontends. Also, we want to experiment a little bit with multi-frameworks microfrontends. Thank you for your attention.